All right, so here we're going to do the example. It's in the notes here, the question is there an association between getting the disease and being exposed to a disease? So they got randomly sampled. Turns out if you add these up, I should have put the totals here. Let me do that in green, because the green represents, those are where the blanks are, and that's where the work is that you're supposed to do. So the totals, and I'm just going to look here. If you add up 37 and 17, you get 54. If you add these numbers, you get 66. 37, 47, this is 50, and this is 70. And either way, if you add these or add these, you're going to get a total of 120. Okay, so there's a total of 120 people in this sample. Okay, so this is what we're given. Now we're asked to fill in the four boxes here, the expected counts. These are the observed counts. We went and got the sample, the 120 people. Some of them were exposed, some of them were not exposed to the disease. And then we said, did they get the disease or not? 37 had the disease and were exposed. 17 had the disease but were not exposed, and so on and so forth. So what are the expected counts? Well, here's our formula for the expected counts. It's the row total times the column total over the table total. The table total is 120, that's why those are all 120, the denominators here. But the row and column total is going to change. So for this is the observed count. What's the expected count for right here? Well, the expected count is the row total. The row total is 50. The column total for this cell is 54. So 50 times 54 over 120, get out your calculator, you get 22.5. Here, the row total is 50. This cell corresponds to this one. The column total is 66. The table total is 120. Get out your calculator, you get 27.5. And then similarly for here, I'll just do this one. The row total for this cell, the row total is 70. For this cell, the column total is 54. Again, the table total is the same for all of them, 120. Get out your calculator, you get 31.5. So these are the expected counts right here. These are what we would expect. These are the observed count. This is what actually happened. So now we're asked to, by hand, calculate the value of the chi-squared test statistic. Well, the formula for the chi-square is observed minus the expected, that quantity squared over the expected. So for this cell, the observed is 37. The expected is 22.5 divided by the expected, 22.5. So here, the observed for 17, that corresponds to this cell. So we get 17 minus the expected, 31.5. Square that, divide by the expected, 31.5. 13, that corresponds to this cell. 13, the observed. The expected is 27.5, quantity squared, divided by the expected, which is 27.5. And our last one, this cell corresponds to this one, 53 minus 38.5, quantity squared, divided by the expected, 38.5. Now get out your calculator. Do the subtraction, square that, divide by 22.5, so on and so forth. Add these numbers up and you're going to get 29.1. So the value of chi-square, the value of the test statistic, chi-square, for this particular example is 29.1.